Um, we're going to talk about a few different things, and I think it's good to set out the tension as it lies at the moment. Um, we know that AI potentially supercharges electricity demand and places stress on systems that are already stressed. But can it also help us to decarbonize faster? Well, we're going to find out. We're going to look at some evidence and we're going to look at a recent pilot project as well. Steve, let's start with sort of framing the problem, if you like. From National Grid's point of view, you're required to plan on the basis of kind of worst case scenarios, if you don't mind me putting it that way. So big industrial draws, it draws full power and the worst moments in the system. So, winter, for example, winter evening peaks. When you look at AI and large scale computing against the UK's climate targets and budgets, what is the core problem that you're trying to solve that you're thinking about? Is it peak demand, lack of headroom, or something that I haven't thought about?
This mic on? That one better? Yep,
That's
there we go.
better.
Thank
Thank
you.
you.
So look, first of all, I think the framing, I think if you start by framing things as a problem, it sort of gets you into the wrong mindset. So I think at National Grid, we've been trying to see this as a big opportunity. We know that we need cheaper energy in this country, and we know that our system and our networks are part of the final cost of energy. So AI customers could be fantastic for us because if we can bring these large loads onto our system without the need for lots of investment, then basically these are big volume users, and that means that the costs for other users come down because they pay more of our costs. So the challenge for us has been, to your point about peak demand, how can we bring these big loads onto the system without the need for significant new investment? And it turns out that technology and ironically even AI is helping us with that. So we're working with a company called GridCare who use modeling to basically really stress test how much power can we push across our system. And when we've run that in our US business, we found there's more capacity on our system than we thought. We can connect more of these data centers than we thought. And then I know we're going to come onto the trial as well. So we've been thinking, how do we use technology? How do we use innovation? How do we work with these AI data centers so we can get them onto the system, bring charges down for other users, but not need a massive build out to connect them?
Thank you. It's probably a bit unfair of me to frame it as a problem. Tension is a better word, isn't it? And thank you again for trailing the pilot, which we will talk about in a minute, but still going to build up the anticipation. Josh, from the AI infrastructure side, what do you think is most sort of misunderstood about AI's power demand at the moment?
If you're looking at that side of the ledger, the demand from AI, and not about the applications of AI that impact the energy sector as well, um, it's absolutely foundational that we need to have power. That's we think of AI as we think of it. We think of AI as a five-layer cake, and energy is the foundational layer. So unless you have energy, obviously you can't do anything, even with these fantastic models that we've already trained up. So being able to access those models definitely relies on energy. Now, one of the biggest misunderstandings, I think, is the quantity of any energy that's required for AI. Absolutely, the new data centers that we have, they draw a lot of power per square meter. What we've innovated to do is to actually bring all just amazing amounts of compute into a smaller and smaller package. And what that means is the same size of data center is going to draw more power, but it's going to deliver far, far more compute than a data center previously could. The energy efficiency growth has been astronomical over the past 10 years. So it's coming in a smaller package, but AI is actually not driving the largest load growth in the world right now. It's things like electrification, buildings and HVAC and so forth. AI is up there, but it's still a relatively small proportion of global electricity. It's down around 0.5% of global electricity demand right now. Absolutely growing, absolutely something we need to manage, but it's something that is manageable on a global scale.
Okay, and big thanks to our sound desk who are dealing with their own power demands this morning. I'm going to stay with you, Josh, and I want to talk about language and this very interesting idea. So, NVIDIA talks about AI factories as grid responsive assets rather than passive power consumers. In practice, can you tell us what does a power flexible AI factory do that a conventional data center doesn't?
So at the simplest level, it implements what they call in the energy world demand response, where when you're getting to that moment where the grid is at peak capacity, a data center can be directed to or volunteer to reduce its energy consumption in that moment and be flexible in its demand to accommodate other less flexible loads that are coming online and things like HVAC in the especially this week in London we're feeling the heat everywhere. I imagine the grid is kind of at one of its maximum stressors this week as we try to cool all of our buildings. And so it's at moments like this when data centers, if they're able to flex their demand, can be flexible. They soak up the unused electrons during other periods of time when the grid isn't at peak stress, but then they can ramp down to be good grid assets during those peak demand hours.
Well, that's a good point. Steve, let's check in on the grid this week. What does the kind of the heat wave and the predicted red alert, what does it mean for the grid in real terms?
So we run systems in the UK and in the US. So in the US, most systems do peak in the summer because of aircon low. So you get your highest demand. The UK system still peaks in winter. So although we'll see, and that's because frankly we don't have as much air conditioning as you do in New York or New England where we operate. So look, the main issues for us at the moment will be it's as simple as transmission lines are made of metal, and when it gets really hot, they get warmer, and that reduces the amount of power you can put down them. It's just something we're used to dealing with, and they're engineered to sustain these sorts of heat waves.
Well, thank you for your service because we we need it this week. I think I read somewhere that only 3% of UK homes have air conditioning, so that may change. Let's get back onto topic. What would need to change in how National Grid models, connects, and contracts with these facilities before you can genuinely treat them as assets for decarbonisation and system resilience?
So just to get back, because you said this and framed it right in the first question. If you think about our system, it only really is stressed for maybe 10 to 50 hours of the year during those peak times. For the rest of the time, including in overnight, summer, things like that, there's no stress at all. So there's an abundance of network capacity and an abundance of generation. So it's really about what can these data centers do, as Josh said, in those peak periods. And actually, we don't need all of them to do it, and we don't need them to be able to shed all of their load. We just need them to be able to do a bit. So all we need, and this is where the trial was really helpful, we just need to have confidence that if the system operator NISO instructs them and says, can you reduce your power by 10% and gives them warning, can they do that? And increasingly what we're seeing is that they can do that. And there are different ways that data centers can do it. They can have their own on-site generation, they can have batteries on site, or alternatively, and this is what the trial was doing, they can actually shift some of their computing load. So either say some of this stuff we're running at the moment isn't time critical, we can just move it by a couple of hours, or alternatively, they can shift it geographically. So they can say, actually, we don't need to do this at this data center. We can move it to another one, maybe somewhere else in Europe, maybe somewhere else in the US.
Okay, so you very helpfully brought in the trial because we're going to talk about it now, everybody. Finally, we get to that bit. So, the live demonstration at Nibius, is that right? New AI factory in London. So, you've pinpointed one thing. What else were you trying to prove about how a site like this can work with the grid?
So there are different levels of response we require. So the famous one, which is sort of relevant now, during football matches and the World Cup's on, you get these massive spikes in demand. Typically, well, it used to be at half time. Now it's going to be at the water break. So every 15 minutes. So
Hydration
yeah,
break, I think
indeed,
we call them.
because what happens then is people go out and being Brits, and this is typically what it was. They stick the kettle on. I mean, maybe these days they go and they got a draft beer machine or something, but you get this big spiking load. So at that point, you need really, really rapid response. So one of the trials was trying to do is we were sending signals to these data centers because that response needs to be in microseconds. We are literally saying in microseconds, we need you to move. And it was very much a question, could they do this? And if you're a nerd or a system operator, you'll have this trace of what you want them to do. And they did it beautifully, probably better than some of the other, big flexible load we have on the system. So it was a real moment where we were able to say, yes, they can do this at a speed, and it's all automated that would make them one of the most flexible resources on the system.
That must have been very exciting.
Well, if you were the nerds like us, and the thing was, it was a double blind experiment, so nobody knew what they were going to be asked to do, and you had the people from Emerald and Nvidia sat there, and they had no idea whether it was going to work. So when we saw it follow this line beautifully, it was like a real sort of woohoo moment. But you have to be a bit of an energy geek to think that's
There's,
exciting.
listen, there's many energy geeks here today, and you're very welcome. So that's good. Okay, Josh, from your side, inside the facility, what did it actually look like in practice for an AI factory to behave in a grid responsive way? I mean, we just heard a little bit about the, fingers crossed moment. Will it work? Will it won't? I don't know if you'd be telling us about it if it happened, but here we are. What did it look like?
Yeah, it's so this is a unique opportunity specifically because AI factories they operate in the digital world, right? If we were talking about a large load like a manufacturing facility, it's a lot more difficult to say stop immediately your energy consumption, be responsive to a lightning strike or the kettle effect or something else. So the fact that this is something that can be orchestrated in software makes it a really, really good candidate for demand response. And what it looks like inside the data center really depends on how the center is built and what loads it's offering up. So, Steve mentioned the three types of flexibility that we can implement. One of them is to say, okay, we're getting close to a place where we need to curtail our energy consumption. Um, we can trigger the on-site battery storage that we filled up our batteries when the electrons were abundant, when energy was abundant, and they're ready to help us serve our load during the peak grid stress. The second way is the way people typically think about, which is to identify which loads are not time sensitive, and those can be flagged, and they are basically just put on a shelf for a little while until you have more energy availability. And the third one is geographic. So if you have a data center that's up in Scotland and maybe they're not at peak grid stress, then you could transfer that workload in space. And it is complex. I mean, it sounds maybe it's hard to convey that this really is a complex issue because you have so many workloads working on it in a data center at the same time, and you want to use those assets as much as possible. But the software that we've developed and Emerald AI's contribution with their conductor platform really does this amazingly well. As Steve mentioned, the response was exactly what we were hoping for in the trial, and was able to accommodate all of the tests that we ran.
Can you give me, you've got some very striking numbers that I've read somewhere or heard somewhere to describe what happens if a data center becomes genuinely flexible, I suppose. Can you share some of those with us and explain what they tell us about the potential scale of flexibility so we know what we're sort of dealing with?
Sure. So in the United States, I think we're at utilization of existing electrical infrastructure. So the percentage of electrical capacity that we actually use for loads is in the 40 to 50% range. I think in the UK you're around 50%, so a little better than we are in the United States. Um, which means there's a lot of headroom there for us to take advantage of unused capacity in the existing infrastructure. And of course, that's the most efficient outcome is if we're able to use more of the energy that's already available to be generated. Um, and there was a study from Duke University last year. Tyler Norris published this that concluded that in the United States, if AI data centers were flexible for just 1% of the year, it could unlock 100 gigawatts of existing capacity in the United States grid. And I don't know exactly what the numbers would be like in the UK, but that's a big number anywhere in the world, 100 gigawatts. So the opportunity is huge for us to get more out of the existing infrastructure. And it really is good for consumers because when you end up paying more for the electricity that's being generated from the infrastructure you already have, it supports efficiency of the energy system and therefore supports energy affordability as well.
Thank you. And just for more context, 100 gigawatts of new load with that blah, 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 roughly the equivalent of avoiding 50 Hoover dams, according to Duke University. Well, Steve, what can you tell us about when you hear numbers like that? What kind of flexibility could you realistically plan around the UK system?
Um, so a couple of thoughts. I mean, it's worth saying. So On our current plans, we're looking to probably connect about 10 gigawatts of data centers over the next 5 years, which is a huge uplift. I mean, peak demand on the UK system is about 45. So that's a big number. And really what this is about is, can we do even more than that? So we kind of have all that baked in. And then once we get the centers on, as I said, how can they actually benefit other customers? So residential customers, but also industrial customers. And we did a bit of maths that said, if we connected just 10 gigawatts of data centers, and before we even brought the flexibility benefits in, that would probably be a reduction in everyone's energy bills, because we'd be charging them for our network and we can push charges down for others of the order of about 25 quid. So about 25 quid off the bill for a domestic customer. For a hospital, it would be more like, 50, 100,000 off their bill. For a really large user, it could be 500,000. So these are really big numbers. So there's a big debate about, well, is it a good idea to connect data centers? To which the answer is yes, it really is, because basically means these big consumers of our networks will allow us to bring charges down for everyone else. And then on the flexibility side, I mean, the system operator spends the thick end of, £3.5 billion a year balancing the system. And, the sorts of services Josh is talking about will help bring those costs down. So it really is win-win before you even get to the jobs this brings, the technology companies that will use these data centers, because, probably we are number two behind the US in AI. If you think DeepMind was founded here, we've now got amazing startups in AI of the physical world, in AI of material science. So it's a real opportunity for the UK in terms of economic growth as well.
Well, you're going to have to convince a lot of people on an environmental basis, to say the least. So, this is London Climate Action Week. So, we need to talk about climate outcomes. And I'm going to ask you now to translate some of this into climate outcomes. Josh, so when you make the case for power flexible AI factories, how are you quantifying the impact in emission terms? For example, if you're enabling higher shares of renewables on the system, reducing curtailment, so where is the climate win?
I think the climate win is actually almost inevitable with AI, as long as we take advantage of it. So, more and more studies from the International Energy Agency, World Economic Forum, Grantham Institute have all concluded that AI is poised to drive net emissions reductions if we deploy it broadly enough. And that's the key variable. Like we've already trained these fantastic models. They're available to help us create efficiencies in other much larger sectors, to reduce energy consumption in manufacturing and buildings and transportation so significantly that it dwarfs the actual footprint of AI. So conceptually, the taking advantage of AI will, I think, almost inevitably drive emissions reductions. Now, the advantage that we have with flexibility is that turbocharges that potential net reduction in emissions by making variable generation like renewables incrementally more valuable, because we're able to take better advantage of those intermittent sources when they're available. So, one of the biggest criticisms that we have, one of the biggest challenges that you have with clean renewable energy, with solar and wind, is that they are intermittent. And if we have really large loads that are demand flexible, that can exhibit demand response, then again, you can soak up all of that generation when it's abundant, and you can pare back when it's not, which makes the value of those intermittent sources higher relative to firm sources. So it really does turbocharge the clean energy transition if we get enough of these AI factories online to take advantage of that intermittent generation.
Steve, you're nodding. Can you do the energy transition without it?
Um, I think it helps in all the way Josh has said. So look, when you build out a lot of renewables, you have to overbuild because of intermittency. And as Josh said, that means there's lots of periods. There have been periods this year when we've had to turn wind farms off because we simply don't have the demand on the right places on the system. So actually, to Josh's point, a lot of the time they will be consuming power that otherwise we just simply say to the turbines, you need to stop turning. We just have nowhere to put this. When we balance the system, frequently we are using gas-fired generation as that balance. So if they can provide that flexibility, we're burning less gas. But fundamentally, I think, as I said, it helps with that affordability. The biggest challenge we have at the moment is the cost of all that renewables build out. So again, if we can spread that cost over a much bigger base, and the data centers are picking up their fair share, it helps make the transition more affordable. So we think it helps in all three aspects. And then the final one I'd add in, which Josh alluded to, who knows what AI is going to do in terms of, breakthroughs in generation technology, storage, and things like that. So I think even if you get, a little bit more gas burned across the world to power I think it's a reasonable bet to say that, in 5 years' time, we will look back and say that was a very wise investment in terms of, the innovation it will unlock in ways to, solve some of the problems we still have with the transition.
Well, I think that might be a hard sell, but we'll leave that for a different time. Okay, so um, just quickly, can you tell me what it potentially means for National Grid's investment plan?
Yeah, so um, I think there are three fundamental things driving investments in networks at the moment. One is connecting up all the renewable generation because our system was built in a world of fossil fuel generation, nuclear generation. So bluntly, it's in the wrong places for the generation we have. The big new wind farms typically are in areas of the country where our network isn't. So that defines part of the build out. The second thing is meeting demand from new sources on the industrial side. That's not just AI. So if you take that 10 gigawatts I talked about, we've got 9 gigawatts of other industrial demand, whether that's electrifying steelworks to new, giga battery factories. So we're seeing that big increase. And then when you get down to the distribution network, it's all about EVs and heat pumps. That bit's a bit more uncertain. And there, for example, we have said, there was a plan to say, we needed to build aggressively for that. And I think we've collectively said to the regulator, we think we can slow down a bit there. We need to get it at
Right.
the right pace,
Yeah.
but we don't think we need to go quite as aggressively as you because we are seeing, amazing pickup of EVs, a bit less so on heat pumps. So let's just get that build at the right level to match that demand.
Okay, right. Um, we have to acknowledge, and I'm sure you do, that there is huge public concern about AI's environmental footprint, not just in terms of climate emissions, but also things like water. How would you characterize the debate at the moment? And do you attribute that to misunderstandings or not understanding how AI is changing? How do you characterize that tension?
So these are good questions to ask. Anytime there's a new build, anytime there's new infrastructure, it's fair to ask about what impact is this going to have on me? Impact is it going to have on jobs and on environmental impacts? But the good news is that actually modern AI looks very, very different from even the AI that we had 2 or 3 years ago, and we've been engineering sustainability into our design very intentionally in ways that make it much more sustainable than it was even a few years ago. And I'm glad you brought up water. On the waterfront, we have now transitioned this year our platform over entirely to a direct to chip liquid cooling system that's a closed loop, and it actually operates at a 45 degrees Celsius intake temperature, which means it's very, very hot. It only has to cool down to 45 degrees centigrade um, before it can adequately cool the GPUs. What that means is not only does it basically consume no water for cooling the chips in the data center, but it also operates much more energy efficiently. And in most locations, you don't even need chillers to cool that closed loop system. So that's one huge step change that we've had in terms of water efficiency that I think not enough people understand yet, because older data centers did consume more water for evaporative cooling, but we've largely solved that problem with this new innovation. And then, as I mentioned before, energy efficiency, we're improving energy efficiency by about 10 times each year. The same AI inference workload that you ran 12 months ago probably uses 1/10 of the energy that it used if you were to run that same workload today. Now we're using more and more, so the aggregate energy is growing, but we're getting more for each megawatt of energy that we use.
Okay, so Steve, we're going to have to wrap up, I'm afraid, just because it's just such a fascinating conversation. If this audience remembers one thing about AI factories, data centers, and the grid in the context of climate action, what should it be?
Well, I know you've expressed a bit of skepticism, but I'd say they're part of the solution, not part of the problem. I genuinely think they can help with affordability of the transition. But the crucial thing there is it has to be done right. We've talked about a lot of innovation. We've talked about water. We've talked about energy. So if we do it smartly and in the ways we've talked about, then they can be part of the solution, making energy more affordable, which will make it easier for us to fund the transition.
Josh, I'm going to ask you to pick one thing to leave us with.
I think I would just concur with Steve that AI is absolutely a part of the solution. It's helping us solve so many problems. Some of those are still speculative, like will it help us unlock nuclear fusion as an abundant clean energy source? Possibly. That's still speculative. But what it's delivering now is real benefit in terms of efficiency in the energy system, energy affordability, incremental value for intermittent generation like renewables. So it's having real practical impacts now that accelerate the clean transition and help us achieve the sustainable future we're all interested in.
Thank you so much. Big round of applause, please, to Josh Parker, Head of Sustainability at NVIDIA, and Steve Smith of National Grid. Thank you so much, guys. Thank you. Thank